In this video, I'm going to show you the planisphere, what it is, how it's used, what information it has on it. Here's the one that you've been asked to get for Astronomy 101. They have it at the bookstore. Hopefully you have it by now. You'll see right away that it's designed for between 30 and 40 degrees north latitude, which makes it specific for places like Redwood City, which is at 37 degrees north. This device has two sides. On the first side, which we're looking at now, you'll notice that it says north. So on this side of the planisphere, what you will see in the window is the sky the way it looks when you face north. When you reverse it, you will see the sky as it looks to the south if you turn around and look in the other direction. The solid blue shows you where the horizon is. So things close to this solid blue line are close to the horizon, near the bottom of what you can see. And then as we move away from the horizon, things are getting higher and higher overhead. On the north-facing side, we have a little more than half the sky, so that we start on the horizon, go up to a point here that would be directly over our heads, and then we go a little bit even to see what's behind us. And then on the south-facing side, we have a little less. So starting at the horizon and going up maybe 60 degrees from the horizon. If you want to see things that are very high in the south, you actually need to look at the north-facing side and look close to this edge here. The planisphere is designed to work on at any given day or time, but at each different day and time, the position of the stars is going to be different. So as you look around the edge of the wheel, you'll see it's marked off in the calendar days, not allowing for a leap year. And then in addition to the days, there are times. So you need to find not just the day that you're looking, but the time that you're looking. As I'm doing this, it is May 5th, Cinco de Mayo, and it is about 7 o'clock in the evening. So I'm going to look and find the date May 5th, and I'm going to adjust May 5th to line up with 7 p.m. And now the stars that it is showing me are in the position they should be if it was dark enough right now to go out and look at them. Okay. Then as the night goes on, we would move a little bit, 8 o'clock, 9 o'clock, 10 o'clock. So all through the night, the position of the stars is changing as you see them. At the center, the point that the sky turns around, is Polaris, the North Star. So start by setting your planisphere to today's date and time. I'm going to go back to May 5th at 7. Now as you look at it in capital letters, here Ursa Major, Leo Minor, Canis Venatici. These are the names of constellations. And then in lowercase are names of stars, Polaris, Castor and Pollux in Gemini. So those are the individual stars, are in lowercase letters, and in capitals are the constellations. In addition to stars and constellations, there's a special group of things they refer to as objects for binoculars. They're going to include things that are larger than individual stars, so that we can see them from very far away. Globular star clusters, open star clusters, nebula, galaxies. They'll have one of these symbols and a name to go with them. For example, here near Canis Major, you'll see M41, and the symbol there is one of these little open circles, so we know that M41 there is an open star cluster. Sorry, need a close-up look. So, in addition to identifying the stars and constellations and telling you which way to look, eastern horizon, south, high or low, western horizon, it will also give you the stellar coordinates of a star. Stars have coordinates that tell their position in the sky relative to other stars. And they work like latitudes and longitudes do, except that they are not relative to positions on the Earth, but relative to positions in the sky. So as we have latitudes, a sky chart has a position known as declination, which tells you how far north or south of the equator something is. You can see them marked along here. The equator is 0, of course. And then as we go up 10 degrees north, 20 degrees north, 30 degrees north, until we get up to the North Star at 90. If we're going south of the equator, the numbers are negative. So as we go south, we'd see -10, -20, -30, and that tells us that we're going towards the South Pole in the sky. The longitude lines are for the sky referred to as right ascension. Lines of right ascension run like longitude lines do from pole to pole. You'll see them all crossing here at the North Pole, just like they would on a globe. Instead of being 0 to 360 degrees, they're marked off in hours. So, for instance, anything on this line has a right ascension of 9 hours. Anything along this has a right ascension of 12 hours. If we wanted to ask where this star Capella is, we would approximate a line through the North Pole, because these right ascension all go through the North Pole. We'd go through Capella to the equator, where we'd see that it was a little bit more than 5 hours. And we could also look over here and see that it was at about 45 degrees. So the coordinates of Capella would be 5 hours and 45 degrees. So that's how to use your device, how to set the proper time, how to interpret the direction of things, and how to read the coordinate system of the planisphere. So now you should be able to go ahead and attempt exercise 1, which will ask you to identify different things in the sky, their coordinates, their directions, and how they move with time. So good luck, and be sure to send me any questions as they come up.